and welcome to Evidence-Based Practice Week 2. We're going to be going through the slideshow again based on the work of Dr. Susan Silva at Duke University School of Nursing. Just a quick review. Evidence-based practice, as we've been talking about, we will continue to talk about, is defined as the use of the best clinical evidence in making patient care decisions. We want to know that we are taking the highest quality of knowledge available about providing care and applying that to produce the greatest impact for health and wellness for patients, families, and communities. The goal is to produce a strong base of evidence through rigorous methods and multiple confirmatory strategies. And we are going to be talking about that multiple times over the course of this term because this is really the core of evidence-based practice and getting quality research to base your interventions on. Selecting an appropriate and strong research design is the beginning of it all. Unless you select and organize a strong design, you're not going to have good outcomes in terms of usable information to guide and shape clinical practice. Confirmation of evidence is needed to ensure that the robustness is intact. And we've talked about that before. Quick review about the levels of evidence. If you can kind of get that burned in your brain and those levels of evidence and know, then that way you will feel confident when you search Cochrane and you know you're getting systematic reviews, that you're getting a strong level of evidence. You will know that when you read the opinions of experts and expert committees that you're getting a weaker amount of or level of evidence, level 7. It's not that it's wrong, but it's just not as strong as systematic reviews. And here's a quick overview again from Pollock and Beck. We talked about that last week, and taking into account those client values and preferences are a frequently ignored or just not attended to component of practice. Okay, we're going to be moving into new material now. If you look at the upper left, in red, it all starts with the research question. These is the components of research. As you can see, it's a very cyclical process that once a question is answered, then that fosters and creates and generates more questions that stimulate further research. So let's go through this. We start with a research question, a PICO question, and then from there we come up with a research hypothesis. As you know from your statistics class, you come up with a null hypothesis and a research hypothesis. And your statistics on quantitative studies either retain or reject the null hypothesis. From that, you will generate a research design, and very much the type of question that you are asking will greatly influence the design of the research. It's like asking first, what kind of a party am I going to? And then from that, you know what to wear. If you're going to a wedding, you're not going to wear shorts and a t-shirt. That would be appropriate for a ball game or a picnic, but not for a wedding. So again, you have to answer the question of what am I looking at, the question, what is my hypothesis, and then from there, let the research design flow out of the hypothesis. Once you have your design in place, it's going to be evident what kind of sampling methods you need to choose. Again, ensuring internal validity is very important with sampling, not to get bias introduced right from the get-go. And we were going to be talking about that over and over again. From there, you're going to gather your data and ensure data quality and strong statistical methods. In terms of data quality, you don't want what Dr. Silva calls dirty data, because then the statistical methods that are run on that might be spurious or not truthful. So you want to go ahead and clean up your data, and what that is involved, especially with large research studies, is making sure that when that data is collected and it's entered into a statistical package to generate some of these complex statistical analyses, that they're not misentered or coded incorrectly. Most researchers, when they're working with large amounts of data and multiple variables, come up with a data dictionary where they code data like 0 is male and 1 is female, so you can quickly sort how many males and how many females you have in your study, and other kinds of descriptive statistics. So you want to make sure that your statistical methods match your data. Many researchers, as we talked about in class, do histograms and stem and leaf plots and other kinds of visuals on their data to make sure that the assumptions are not violated. All the statistical methods used for analyses are based on mathematical principles that assume a normal distribution, a bell-shaped curve. And if you have a lot of skew in your data, or if they're not normally distributed, then you cannot choose a parametric test to analyze that data. You have to choose a non-parametric test. And we're going to be talking about that more in class. I showed you some outputs from SPSS, the statistical package for social sciences, essentially the software that generates these statistical analyses. I showed you some outputs from that, and I will be copy and pasting that and putting that on PAL for you to see as well. From that, you get your statistical results, which we've alluded to a little bit, and there you're going to interpret your statistical results and either refute or retain your null hypothesis. From that, you're going to make some interpretations that might generate some additional questions for further research, and there the cycle starts again. The research question looks at the problem and the study population. Again, that is the population of interest, and of which we're going to get a sample. It's virtually impossible and economically unfeasible to poll every single person in a population of interest. So we choose a representative sample from that population to obtain a sample, so we can intervene or test that sample in some way, shape, or form, and then turn around and make inferences to the population of interest. We're going to come up with research questions that have specific aims, and typically the research hypothesis has a predictor variable, that's usually X, and an outcome variable, that's usually Y, and that must be stated in the hypothesis. Again, the research question will define the paradigm, what we're looking at, either qualitative or quantitative research. Again, qualitative looks at the quality of something, like the meaning or the purpose, and the quantitative looks at quantity, how many, how much, how big, how small. You are going to identify what phase of research it is, and we'll talk about that as we go along, the nature of the study and the research design. It is key that you have the X and Y variables clearly defined, and we're going to be talking more about causal inferences. Does this cause that? And only true experimental designs can draw causal influences. There might be a relationship between two variables, but we can't say that X causes Y unless we do a true experimental design. In terms of sampling methods, every member of the population must have, in order for it to be representative, have an equal chance of getting in your sample. So going back to the ice cream example that we frequently have used in class, if we are interested in finding the favorite ice cream flavor of Polk State College students, if I sample only nursing students in this research question, then every other student at Polk State College will not have an equal chance of getting in that sample because they don't take nursing classes. So that will really not yield a representative sample of Polk State College students. In terms of sample size, again, if I get a sample of 200 or 300 students, that might be very representative of the Polk State College student body population. But if I only get 10 or 15 students, that's not going to be an adequate sample size to reflect the inherent variability of that population. So sample size is very, very important. Again, we're going to be looking at the type of sample and the recruitment method. If I just stand outside on Mondays and hand surveys out to students that walk into the student center, again, that's not going to be a very effective recruitment plan, because what about the students that never come to the student center, or that don't have class on Monday, or take online classes and don't come to campus at all? So you can see how recruitment plans really affect the representativeness of your sample. Representative sample will influence the statistical power. The smaller the sample, or the more biased the sample, the less likely you are to have power enough to answer the research question. We hinted a little bit about design elements and internal validity. These elements to enhance statistical power are key to having a usable study. If you're going to go through the time, effort, and energy to conduct a research study, you want to make it mean something. You want to have results that have an impact. So you want to maximize elements that enhance statistical power. You want to enhance elements that will get at the fidelity or the trueness of the intervention. You want to know that your intervention results are really what happened and not out of chance or error. And then when that study's replicated, the findings are radically different. We have talked about this before and will continue to talk about this. You want to avoid selection bias at all costs. These are threats to internal validity. We're also going to be talking about threats to construct validity and external validity in future lectures. Overall, you want to enhance all the elements of the validity of your study. You want to choose instruments that are valid and true and reliable, and measure what you think you're going to measure. So these are all elements that must be carefully thought out before the first piece of data is ever collected. In terms of data quality, you want to operationally define your measure. You want to measure what you think you're measuring and not something else. The reliability and validity of your measures are key. You want to choose data collection tools or measurement tools that have proven to be reliable and valid. All of us use the pain scale, the 1 through 10 scale, with confidence in clinical practice because that has been researched ad nauseum. We know it's reliable. Every time we use it, it measures pain and not another variable. We know it's valid or true, that when we use that measure, we're really getting at pain and not some other variable. The impact of poor data quality is very significant. When you run statistical analyses, your outputs or what you derive are only as good as your data. If your data is dirty or sloppy, then you're going to get sloppy outputs with results that don't mean anything. So it's very, very important to get good data quality and be careful about what you measure. In terms of descriptive statistics, we're looking at overall sample characteristics, or the N, the number of people that are in the sample. How many are male? How many are female? How many are old? How many are young? How many are different kinds of races? How many are different kinds of variables, such as do you have diabetes or don't have diabetes? Do you smoke or do you not smoke? These are all these kinds of descriptive statistics that essentially describe your sample. Within that, you might have group characteristics and comparisons, and you will be able to look at key predictor and outcome variables and assess adverse events, safety measures, and harm indicators. So as much descriptive statistics as you can obtain about your sample, the more inferences you can make. In terms of inferential statistics, I'm talking about statistical methods using parametric and non-parametric tests. Again, parametric tests are stronger than non-parametric tests, but they can only be used when the sample size is large and the data is normally distributed. From that, we can make estimations or inferences about the population and test hypotheses. We can also infer whether our statistical conclusions are valid and make statistical summaries. When we interpret findings from a study, we're going to be looking at causal inferences if it's a true experimental design. Did X cause Y? Sometimes, and I would like for you to have these concepts well understood? Because I can promise you it will pop up on quiz number 3. I want you to understand the difference between statistical significance and clinical significance. Many times studies are small, and this happens a lot in nursing studies. Studies are small and it may not yield statistical significance, but have clinical implications or significance. So I would really like for you to read those concepts and understand that. When we talk about variable relationships, we talk about relationships between variables of interest. So, is there a relationship between X and Y? A research hypothesis will express a predicted relationship. It can be either two-tailed, we don't know which direction it will be, so there is a relationship, or it can be one-tailed. There will be a positive relationship between X and Y, indicating as X increases, Y will increase. Or there will be a negative relationship. As X increases, Y decreases. So quantitative designs can help us answer the following questions. Does a relationship even exist at all? What is the direction of the relationship? How strong is the relationship? And what is that nature of the relationship? Non-experimental and quasi-experimental designs allow us to make statements about the degree and direction of association. There seems to be a weak positive relationship between X and Y. There seems to be a strong negative relationship between X and Y, but one must be cautious about making inferences about cause and effect. Experimental designs allow you to make those inferences between cause and effect. The statistical analysis plan. Research, hypothesis, and design, again, determine the statistical approach. We've talked about that a little bit already. And statistical methods must address the hypothesis. Operational definitions and level of measurement of X and Y variables influence the analytical approach. So whether a study is, say, longitudinal in nature, or whether the data are normally distributed, often influence the method chosen to analyze the data. This entails making sense of the study results, the interpretation of results. Resist the temptation to make more of the results than the design and the analysis allow. If your study looked at adolescent Hispanic females, you cannot infer that those results hold true for white adolescent females or African American adolescent females. So resist that temptation. If the study design and analysis are restricted to a certain population, that's the only population that you can make inferences to. And that has to do with your external validity. Interpretation involves determining how the findings can be used in clinical practice. We'll talk a little bit about experimental design, quasi-experimental design, and true experimental design. In non- and quasi-experimental designs, the researcher does not actively introduce an intervention or exposure, but just observes. Experimental design, a researcher actively introduces an intervention. Again, be careful about cause and effect relationships. In experimental designs, X is usually called the independent variable, Y is called the dependent variable, and dependent variables are known as outcomes or primary endpoints, and these types of designs can investigate cause and effect relationships. Quasi-experimental designs, the X variable is often referred to as independent, even though it's not manipulated. The Y variable is frequently called the dependent or outcome variable. And again, be cautious with cause and effect statements. For non-experimental designs, X is often referred to as the predictor variable. The Y variable is the response or outcome variable. And again, please be very careful with cause and effect inferences. You can say X predicts Y, X is associated with Y, or Y is related to X, but you cannot state anything beyond that. Okay, so I hope that's been helpful to you, and I'll see your comments on the discussion board. Bye-bye.